Hey everybody, this is your 7.2 pre-calculus video. So before doing more inverse trig functions, I wanted to talk about this problem, which was on 7.1. So the first step, like what I told you on the other video, is to go ahead and go to the calculate screen. And you want to do, let me clear this. You want to do inverse sine of 11 pi over 8. And as a decimal, I get negative 1.178. Now, what I mentioned was, your first step, try 11 pi over 8, but that was not going to work for sure. Also, you might want to try negative 11 pi over 8, and also try 11 minus 8, which is 3, so 3 pi over 8, and negative 3 pi over 8. So those should be all your different combinations. And so if I do 11 pi over 8, I get 4, which isn't right. Same thing if I do negative. But if I do negative 3 pi over 8, I do get it. So negative 3 pi over 8 is my answer. Now, I also wanted to take just a moment to get into to how you would really do it if you didn't just try different numbers, like 11 minus 8 is 3, and so try negative 3 because it's negative. So how I would go about it if you didn't want to just use your calculator and guess and check is first say, where is 11 pi over 8? Well, if this is 0, this is pi halves, which is like 4 pi eighths, then this is pi, which is 8 pi eighths, and this is 3 pi halves, which is like 12 pi eighths. And this would be 2 pi, which is like 16 pi eighths. Then 11 would be right in front of the 12, so you'd be in this quadrant. So right there. Now, to get your reference angle is from the origin. And I basically already showed you how to get it. It's this, and if you do 11 minus 8, so 11 pi eighths minus pi, or 8 pi eighths, you get 3 pi eighths as your reference. And that's where we are. And then based on doing sine, it had to be negative because you're below the axis. Below the x-axis, so minus 3 pi eighths. So again, that's with doing inverse of regular sine. Okay, so I just wanted to mention that. Now, on this lesson, we're going to do other ones like inverse sine, inverse cosine, inverse tangent, as well as inverse secant, inverse cosecant, and inverse cotangent, and using the calculator. So these are your areas where it's defined. So it's defined from 0 to pi for y, And then this one is from negative pi halves to pi halves. And this one's negative infinity to infinity with parentheses for x. And then 0 pi with parentheses for that one. So here are your things. Now, my hint was graph the triangle in the quadrant and then use the Pythagorean theorem to find the radius. And also, just a little comment, most calculators other than the Inspire don't have these buttons. And so the easiest way is to convert to the one whose range is the same as the one to be evaluated. For example, inverse secant of 3 is the same as cosine negative 1 of 1/3. That is interesting. I think we can also say inverse secant of 3 as a decimal is the same as 1 over cosine 1 over cosine negative 1 of 3. No. We'd have to do 1/3. Inverse cosine 1/3. Okay, so there you go. So it's not equal to 1 over cosine negative 1 of 3. Okay. So fortunately, in your case, we have the calculator that has the trig button. Okay, so here we're going to start working these, and we have inverse tangent is negative square root of 3. So when we think about that, we can say x equal inverse tangent of negative square root of 3. Now, if we solve it like the equation, like on the last section, we say do tangent to both sides. So tan x equal negative square root of 3. And to get tangent, remember that's y over x. Now, I don't want to make it more complicated, but you might want to say this is theta instead, because we need like x comma y, like that. So what we want is negative square root of 3 over 2 and then 1/2. Or we want negative 1/2 with positive square root of 3 over 2. But I think based on needing to be in this quadrant, that it had to be this one. I kind of went over this on the last lesson where your 2's would cancel when you're dividing, and then it's negative square root of 3 over 1, which is negative square root of 3. So now we need to pull out our unit circle and say, where did that happen? So, unit circle for 1/2 comma negative square root of 3 over 2. That happens at 5 pi thirds. So theta equal 5 pi thirds. Now, that was over here, which is the same thing as saying backwards pi thirds. And then that's the inside part. And then we have to do sine of 5 pi thirds. And that'd be your y answer, which is negative square root of 3 over 2. So that's kind of like a roundabout way to do it. Basically, you take your angle, do tan figure out where you have to be, and then since you want sine of it, then it's the y answer. So like that. Now, again, for those of y'all that just like trying things on the calculator and guessing and checking, remember you'd have to be in radian mode and do sine of inverse tangent of negative square root of 3, and that gives me this, and then you'd have to guess and check until you find it, but it's negative square root of 3 over 2. Which is that. So if you use your calculator, you get negative 0.866, and then that's equal to negative square root of 3 over 2. But again, I showed you how to do it without that. On the next one, we have inverse sine of cosine of 5 pi over 4. So our first step would be, what is the ordered pair for 5 pi over 4? So we go to 5 pi over 4, and it's negative square root of 2 over 2 for both. And so our cosine answer would be the x, because remember, I sometimes ask you, does cosine relate to x or y? Cosine relates to x, sine relates to y. And so now we have to do inverse sine of negative square root of 2 over 2. Now where that happens, since you have to be in this interval, is down here, where you're at 7 pi 4s, which is the same as negative pi 4s. And that's your answer. Now again, if you were trying to just use the calculator and you did inverse sine of cosine 5 pi over 4, then you get negative 0.785. And you'd have to guess and check until you get to negative pi over 4. It's not a square root one. It's like square root of 2 is 1.414. Square root of 2 over 2 is 0.707. Now, taking the square root is not the same as just dividing by 2. It's basically 1.4 times 1.4 gives you that. So if I highlight it by pressing up, press enter, and then times this, I should get 2. So that's how it's all related. Now, on this one, we need inverse cosine of sine of negative 7 pi over 4. So if we go to 7 pi over 4, that's over here. That's positive 7 pi over 4, but if we go negative 7 pi over 4, we'd be up here at just regular pi 4s. And, you know, that's your answer. Now, I'm trying to think of another way, because I know some of y'all don't always do it the right way. If it's 5 pi 4s, then try 5 minus 4 is 1. So try pi 4s and negative pi 4s. And if this one was 7 pi fourths, then 7 minus 4 is 3. And so try 3 pi fourths. But that was not the answer. You also want to think, like, from over here, it could have been like 8 minus 7 is 1. So try pi fourths. I really don't like just guessing and checking because that sounds fake or whatever. I'd rather get it like the right way. So we go to backwards 7 pi fourths. So that means go all the way around to here and you're at pi fourths. Now, again, comment to make. Sine is on the outside on number 1. And so you want something on the unit circle. Now in this one, sine negative 1 is on the outside. And so we want an angle. And negative pi fourths is an angle. And on this one, cosine negative 1 is on the outside. So you want an angle. So there are different type problems. It is going to take some getting used to. Now this one, it wants a number, not an angle for tangent. Wants a number, not an angle. So we basically need to say sine theta equal 9/10. So that's the opposite over the hypotenuse. Sine would be positive in this quadrant, because remember we would have to be in one of these two quadrants, the negative pi halves to pi halves, and we are up there. And we call this the reference angle, and this is the opposite, this is the adjacent, and this is the hypotenuse. So we put 9 here, we put 10 here, and call this x. So you do x squared plus 9 squared equal 10 squared, x squared plus 81 equal 100, subtract 81, x squared is 19, so x is plus and minus the square root of 19. And then based on where we are, we're at positive. Now, you use that inside part in order to finish your table, or your triangle, I mean. Use the inside expression for your triangle. And then once you have it drawn, then you do the trig function. Then do the trig function to that triangle. And so tangent is opposite over adjacent. So that'd be 9 over square root of 19. And Math Excel would accept that. But if you'd rather get it perfect on the paper, you have to multiply by square root of 19 over square root of 19 and get 9 square root of 19 over 19. Again, that matches this. Okay, now on this one, we have inverse sine and we have negative square root of 2 over 10. So first thing is we would say sine theta equal negative square root of 2 over 10. And we'd have to say, I know I have to be down here, and my opposite is negative square root of 2, and my hypotenuse is 10. And there's my adjacent. So we have to do the Pythagorean theorem and call this x. So x squared plus negative square root of 2 squared equal 10 squared. X squared plus 2 equal 100. X squared equal 98. Wait, negative square root of 2 squared. Yeah, that is 2. Okay, so x squared is 98. And so that means x is plus and minus the square root of 98. Now, like I've said before on simplifying square roots, there's different ways. One is just it's even, and so you go 2 times 49. Some of y'all may prefer writing it as the square root of 98 is the same as the square root of 49 times the square root of 2, which is 7 square root of 2. Some of y'all may prefer doing 98 divided by x and look in your table and look for, 1, 4, 9, 16, and you end up looking for 49. You want your biggest one. So, excuse me, jeez. If we have 98 divided by x, and we go in our table, it's like 1 times 98, it's like 2 times 49, which is kind of convenient. We don't really have to do the 4 or any of these others, So that means square root of 2 times the square root of 49 is square root of 98. So you can use this calculator trick to say x times y equal 98, basically. So y is 98 over x. That's why it works, but it's a calculator trick, to have it do the table for you. Now, once we have that value, we think, well, is it positive or negative? It's to the right, and so it's positive. And then we want cotangent. Well, before I even do cotangent, I think cotangent is 1 over tangent. And so I want to do tangent first, which is opposite over adjacent. That's just the way my mind works. So I want to do negative square root of 2 over 7 square root of 2. And so that's negative 1/7. And then once I have negative 1/7, then for cotangent, I flip it, and so that's negative 7. Because you flip it upside down, and that's your answer. So that's how you're supposed to do it. Now, as you can see, if you already have the answer printed, if you went to the calculate part and did cotangent of inverse sine of negative square root of 2 over 10, then it gives you negative 7. So that one you would have lucked out to get the integer. But like this one, you would have gotten a weird decimal. So that's why it's not always reliable. At least you can see what decimal you're working towards, which is why I don't mind that. But you need to actually get the right answer, like the exact answer. And like this one, we have inverse tangent is negative 4. So if I say tan theta equal -4, then that means I can write that as -4/1. And this is my opposite, and this is my adjacent. And we said before, whenever it's tangent, you're going to have to use these two quadrants. And based on it being negative, you have to use this one. And so here's your angle, here's your opposite, here's your hypotenuse, here's your adjacent. So we've got the opposite to be -4 and your adjacent to be 1. So now we have to do the Pythagorean theorem, and this time we just call this C, or you could call it R, it doesn't matter. C squared equal 1 squared plus -4 squared. C squared equal 1 plus 16, so you get 17. C is positive and negative, square root of 17. And since it's slanted, which is the hypotenuse, you have to use the positive. So this is now square root of 17. Now that the triangle's drawn, then you have to do sine of the triangle, basically. And so that means opposite over hypotenuse. And the opposite is -4, and the hypotenuse is square root of 17. And so that answer would be equivalent to that one, because you multiply by square root of 17 over square root of 17 to get it. Again, Math Excel would accept this answer, but if you want it on paper, perfect, it's that. Okay. On the next one, we have inverse sine of 2 square root of 6 over 9. It's kind of random. Well, we can say theta, or actually sine theta, is 2 square root of 6 over 9. And based on it being sine, you do opposite over hypotenuse. And it's sine, so it has to be in one of these two. And based on it being positive sine, it has to be in this one. And here's your angle, here's your opposite, here's your hypotenuse, here's your adjacent. So we put 2 square root of 6 here, and we put 9 here. Now, I'm going to just call this x. We could say x squared plus big parentheses 2 square root of 6 squared equal 9 squared. Now about this, you can think of it as 2 squared times 6, because 2 squared is 4, and square root of 6 times square root of 6 is 6. So that's one way to do it. What I want to make sure you do is don't just square 6. You'd probably want to do it like 2 square root of 6, and then make sure you move your arrow over to the right enough, and then do squared. And so we get 24. And 4 times 6 is also 24. I meant plus right there. Equal 81. So then you want to do subtract 24, and you get 57. So x is plus and minus square root of 57. Now based on where we are, it's positive square root of 57. All right. Now the triangle's drawn, and so secant is the same as 1 over cosine, and so because of that, I want cosine of the triangle. And it's the adjacent over the hypotenuse. If you want to skip to it, secant's the hypotenuse over the adjacent, but I just don't work that fast. If you do the adjacent over hypotenuse, you'd get square root of 57 over the hypotenuse, which is 9. And so then Secant would be 9 over square root of 57. Now you're going to say those aren't equal. Well, let's figure out what it is. If we do 9 divided by, I just did 6. If you do 9 divided by square root of 57, we get 1.19. And if we do 3 square root of 57 over 19, we also got 1.19. So this is going to be one where, you know, I would just answer it as this. And Math Excel will count it right, or at least it should. Now, if you want to try to get to that number, you'd say 9 over square root of 57 is the same as 9 square root of 57 over 57. And then I'd type 9 over 57 in the calculator, and 9 over 57 is 3/19. And so that's why they have 3 square root of 57 over 19. So it all does make sense eventually, you know, if you get to that point. But I would just type this one. Okay, next we have this one, and we're doing inverse cosine of sine of 5 pi thirds. So this one, we need the angle. We're looking for the angle. So what we do first is say sine of 5 pi thirds is what? So 5 pi thirds, the y value is negative square root of 3 over 2. And then find where cosine of theta is negative square root of 3 over 2. And it's right there at 5 pi 6. So you basically use your unit circle. First we had to go over here, and then we had to go over there. Okay, on this next one, we're doing inverse cotangent of -1. So tangent is y over x, and so cotangent would be x over y. And if it's 1, then it's like the same number for x and y, except for one of them's negative. And you had to either be in this quadrant over here, something with a denominator of 4, or you had to be over here, something with a denominator of 4. So you could also say cotan theta equal -1, and then that had to be in this quadrant. So that's your 3 pi force. So 3 pi over 4. Now, if you can't get it that way, also go to this one. I mean, this was your answer. But if you can't get it that way, then go to this one and say 7 pi over 4. And then in the calculator, try 3 pi over 4 and try 7 pi over 4. And see which one works. So first I'd say try cosine -1 of -1 and see what you get. So if we do inverse cosine of -1, we get pi basically. Oh, I typed the wrong thing. This is COT. I need to do inverse cotangent. So inverse cotangent of -1, and that's 2.356. And so if we do 3 pi over 4, we get 2.356. And if we do 7 pi over 4, we get 5.5 basically. And so it would have been the smaller answer. So we need the exact 3 pi over 4. Now notice this is not like a square root type answer, it's 3 pi over 4 because we want the angle. We want the angle. So I might start asking y'all, well, what does your problem want? Does it want an angle or does it want a number? Again, if it's -1 on the outside, want the angle. If it's just a number, like, you know, if it's a regular trig function, then it wants the number. And you have to get the angle from the triangle first. Make the triangle, and then get the answer from the triangle. Get answer from the triangle. Okay. Moving on, this time we have cosecant and negative square root of 2. Well, we can say cosecant theta equal negative square root of 2. Well, you also know that'd be the same thing as negative square root of 2 over 2. Over 1. And we know cosecant relates to sine, and so sine would have been -1 over square root of 2. Well, that sort of rings a bell, doesn't it? Well, that would be like negative square root of 2 over 2. Where does that happen? Down here and down here. We want to be over here. Well, where was y equal to negative? Where was y equal to negative square root of 2 over 2? Over here at 7 pi fourths, or over here at 5 pi fourths? 5 pi fourths and 7 pi fourths. And we would need to be in this quadrant. So 7 pi fourths is out of range, and so you just need your coterminal, which is like backwards pi fourths, because 7 pi fourths is equivalent to backwards negative. Like, you put negative pi fourths. Okay. Now this one, we're doing inverse cosecant of 2, and so cosecant theta equal 2 means sine theta is 1/2. And so where is y equal to 1/2? It's over here at pi 6 and at 5 pi 6. And you have to be in this quadrant. So it's pi 6. Hopefully you'd be catching on and starting to go a little bit faster. Now, on this one, you can just straight use your calculator and round to the 100th, which means 2 decimal places. You do inverse cotangent of -2. That gives me 2.677, some more stuff. Well, based on this number, we round up. and so it's 2.68. There you go. And then on this one, we do inverse cosecant of -5/4. Now, again, these mean give me the angle, but the trick is this is not in terms of pi. It's just regular radians. Okay. And then here, inverse cosecant of -5/4. Negative 0.927. And so rounding that, you get -0.93. So that's your answer. And then on this one, inverse cotangent of -9/5, and that's 2.634, and so that's 2.63. So we finished up those last ones pretty fast because they're all calculated. Hope that helps. Have a good one.